Before I start the lecture, any of you have any questions or concerns before I tell my concerns? Anyone? So I graded your exams as you saw on Canvas. The average of the class is 60, and almost more than half of the students, less than 2/3, but almost 2/3 are failing, or they're getting lots of students are getting D's and F's. And as I emphasized a lot before, you may have friends last semester that told you, just take the class, tell her you care, and then she'll get an A. Last semester, students were under lots of pressure. They had instructor change, and I gave them so many extra credit opportunities, which I'm giving this semester too, by going to SI Pass and tutoring. And this semester, if you're failing right now, most probably you're going to fail, unless you decide to study, okay? And as I told you, after each hour that I teach in the class, you should study 1 hour. And that is excluding going to SI Pass, that is excluding doing the homework assignment. So how many of you, and then it's just not some students, they don't study during the semester, or like today after I teach, they close the book if you have the book, or they don't go review the materials, and then again they come to the class next session. But before the exam, they study 20 hours or 10 hours, and they say, they tell me that I studied a lot. If you just study a lot the night of the exam, probably you're not going to do well, and you saw the result in the exam. So how many of you, each lecture that I teach, you go home and review that at least for 1 hour? So on average, each week you study 3 hours or more. How many of you? You see few of you, right? And then probably you're doing well in the class too. And if you're not, just contact me. It's negative energy. Just by my iPad. Anyway. Okay, so contact me. I'm here to help you, and I do my best to help each and every one of you. So if you decide to pass this class or get an A or B, I make sure that happens. But you should study. And you should contact me. We should do tutoring, okay? And I should see the progress and all that. But as it is, if you just say I care and then email me and then say, okay, what should I do? And I tell you, okay, study more, or how go to SI class, or have tutoring with me, and then you don't follow up on that, it goes without saying that you cannot improve your grade. Any questions about everything I said so far? So if you got D or F on the previous exam, as I said, it's likely that you're going to fail the class. And if you don't have time to study, I encourage you to drop the class, because I don't want my course hurting your GPA. But if you decide to stay, you should study hard. Okay? Any questions about that? So how many of you, if I decide to have makeup exams, how many of you would like to take it? Okay, most of you. So what I'm going to do, I'm going to send an announcement on Canvas and ask you what time you are available next week, not this week. This week I want you to study, okay? So this would be short notice. And I had this last semester too, that I would schedule makeup exams for students, and they would receive lower grade, or the same grade, or like maybe 1 point higher, because they wouldn't study. So when you want to take the makeup exam, you should study for that. Otherwise, you don't see any improvement. Okay? So I'll send an announcement on Canvas. I'll ask you next week when you are available. And meanwhile, go to your SI test. You have excellent resources, extra resources as well for this class. And then as you see, they sit in the class. They were like my top students last semester, and they can answer your questions. Yes?
I haven't checked it on Canvas, but are the answers, so we could go refer back to our...
Yes, I'll post them. Great question, thank you. And you had 7 different versions, and now I'm wondering, the first exam, as I told you, it was less materials, it was easier, but now, as we progress with the class, it would be more materials, and as you see, there is no opportunity for anyone to cheat. And if I catch you cheating, as I said, you automatically failed at a specific test. So don't think of any unethical alternatives to pass this class. For you to pass this class, you should learn the materials. And I do my best, and I always tell this in my classes, that I just feel like I put part of my soul, if not all, in my classes to make sure all my students succeed. So as long as you want to pass this class or get an A or B, I make sure that happens. But you should give me the opportunity, okay? You should give me the chance to have tutoring with you. And I'm also going to send another announcement about extra office hours. So, and I'm also going to post extra office hours, so I have the chance to go over some materials, especially for those of you who need extra help. Okay? Any questions? Concerns? Good? Okay. So we talked about chemical reactions, and since I talked 10 minutes, I'm just going to continue teaching. So if we have 1 or more substances that they convert to 1 or more other substances, we call this process a chemical reaction. Okay? And we had And we had different types of reactions. Can anyone tell me what were some types of reactions? Do you need any help with cleaning that, or are you all good?
I may need to find somewhere that has more cleaning supplies to put down.
So what did it fall? What was it that it fell?
It was coffee.
Oh, okay. So nothing dangerous. I was what is it? It had mercury in it, or whatever. So that's okay. So at first I was chill. I was okay, probably it's nothing bad, but I was okay, wait a second. Okay. So can anyone name some types of reactions? Yes?
Color change.
What's that?
Color change.
So color change is an evidence of a chemical reaction, which is correct. But if I say different types of reactions, yes? Acid-base reactions, yes. What else?
Redox.
Redox, exactly. What else? Combustion, yes. Yes? Precipitation, yes, that would generate precipitate, yes. Gas evolution, okay. So we had different types of reactions, and we went through them. So make sure that you know how to distinguish different types of reactions, right? So how can you distinguish combustion reactions? If I give you a reaction and I say, is the following combustion reaction or not?
Produce heat.
Produces heat, yes. What else? So yes, so basically producing heat, right? Kind of yeah. Yes?
Electron transfer.
So electrons are transferred. Technically, it is correct because all combustion reactions are also oxidation reduction reactions. So that is correct, but what is specific about combustion that distinguishes that from redox?
Transfer of oxygen.
Exactly. So we have one substance that reacts with oxygen and produces oxygen-containing species. And most of the time, when you have compounds that they have carbon in them, for instance, CH4, right? So if we react that with oxygen, we should have, in our products, we should have carbon, hydrogen, oxygen. Remember, based on law of conservation of mass. So elements, if we see these three elements on left side, we should see the same elements on right side. I won't see like sodium all of a sudden on right side. Does that make sense? So in this case, the products would be carbon dioxide plus water and plus heat, as we said. So if you have carbon and hydrogen on left side, your product would be carbon dioxide and water. And you can kind of remember that to help you. And these are like in gas phase. Water can also be in liquid phase, but as I told you, I don't ask you the phases or like states. I don't say, is water, liquid or gas, so you don't have to worry about it. But when you see this, most students are tempted to think that this reaction is gas evolution because you see CO2 in gas phase. But this reaction is combustion reaction, okay? Does that make sense? Yes?
Would CO2 in the gas phase always be a combustion reaction, or in some cases would it be a gas evolution?
It can be gas evolution reaction too. Great question. So your friend asked, is it always, if you see CO2, is it always combustion? And the answer is that no, we have gas evolution reactions that they produce CO2 too. But the difference is that here you see, something reacts with oxygen and it produces oxygen-containing species plus heat. So basically these two components here, O2 and heat, tells you this is combustion reaction. Okay? Good? Kind of like review of what we talked about before. And I encourage you to go to SI Pass, and I try to solve as many examples as I can during the class, and also in the tutoring session and or extra office hours that I have myself, I try to solve more questions. But I kind of have to lecture, quicker, so you'll be up to date with the course material. So when you go to lab tomorrow, you know what to do, and don't suffer during your lab. Anyway, so we talked about calculations in chemical reactions, okay, or in chemical equations. And the numerical relationship between reactants and products is called stoichiometry. And I'm going to write that in the next slide too. And what we talked about last session was that a chemical reaction is similar to a cooking recipe, right? And your book has specifically talked about making baking or making pancakes, right? And we said we have if you have 1 cup of flour, 2 eggs, and then half a teaspoon baking powder, we have 5 pancakes. And I asked you, what about if I have 5 eggs, right? And knowing I have everything else to the right amount, if I have 5 eggs, how many pancakes can I generate? Or let me ask 6, so it would be more straightforward. How many pancakes? 15, right? Because now you say that this is if I multiply 2 by 3 would be 6, or 6 divided by 2 would be 3. So I should multiply also 5 pancakes by 3. So it would be 15 pancakes. Or basically, this is equivalent to writing a conversion factor, right? So this was an easy example, so we just did it in our head. But if it's if I would ask you 5, it would be easier to write a conversion factor, okay? So now if I ask you, so I tell you that, okay, you gave me this cooking recipe, thanks, I have the recipe now. And I tell you that I don't have 2 eggs. I have only 1 egg, okay? So I have lower amount that I should have. So that eggs is limiting me having the right amount of pancakes. Does that make sense? So if I tell you, let me like formulate the question or write it here. So I tell you I have 1 cup of flour exactly. Okay, so it's like end of my packet or like the batch that I have. So I exactly have 1 cup, no more. And I have just 1 egg at my refrigerator. So I tell you, and then I have like half of, teaspoon baking powder as well. So I tell you, with this amount that I have, how many pancakes can I make? How many do you think is the answer? Is that obvious what I'm asking? 2.5, right? So one of my pancakes would be like smaller. So, but if we consider each of them as like, 1, right? I will be having 2.5. Does that make sense to everyone? Right, pancakes. And I give you like easy examples so we don't have to write conversion factors, just kind of like do the calculations in our head. So what if I tell you, unfortunately, I don't have any eggs at the refrigerator? How many pancakes can I make? 0, right? So I can mix, flour with baking powder and I get some dough or whatever. That won't be pancake, okay? So this is really similar to chemical reactions. So in chemical reaction, and I tell you, in this example that I gave you here, 1 cup of flour, half a teaspoon baking powder, and then 0 eggs. Which of these ingredients limited my reaction or limited the production of pancakes? Eggs, right? In both of the examples that I made, previously, we couldn't make 5 pancakes because of eggs. If I had more, I could have made the right amount, right? So we call that, if this was a chemical reaction, this was my limiting reactant, because that limited the production of pancakes. Does that make sense? Good. And this number that we get here in either of the examples, okay, we call that, in the language of chemical reactions, we call that theoretical yield. So remember, yield, and tomorrow when you go to your lab, it can get confusing. You were like, what was yield? Was it a ratio? Was it like reactant over product over, what was it? Yield is simply your product. And if you have like multiple products in exam in your lab, we specify which product we mean. So you don't have to worry about it, okay? But remember, yield means product. And theoretical means theoretically how many pancakes you can make, okay? So in the original example here, if we have, 1 cup, 2 eggs, half a teaspoon, so these 5 pancakes is our theoretical yield. Or in the second example, 2.5 pancakes, in the next one, like 0. These are our theoretical yield, meaning that theoretically, if I have 1 cup of flour, 2 eggs, half a teaspoon baking powder, I can make 5 pancakes, okay? But imagine that I'm making the pancakes, on the stove, and I burn 2 of them. Or when I'm like putting them, from the pan on the table, I drop 1 of them, right? So if I burn 2 of them, if I accidentally, I guess, I don't think intentionally I do that, right? Burn 2 pancakes, how many would I have in the first example? In the original one that your book wrote? 3, right? I mean, if you just look at the first one, it would be like 5 minus 2 equals 3. So this is the actual number of pancakes that I get. So this would be my actual yield. Does that make sense to everyone? So we had like several terminologies, but hopefully you understood them well based on the explanations that I gave. So limiting reactant is a reactant that limits the reaction, right? The theoretical yield is the amount of product that can be produced based on limiting reactant, okay? Again, remember that if you have like 1 egg, you cannot make 5 pancakes. You only get 2.5, and you use this 1 egg in your calculations. And then actual yield is the actual amount of product that you get in a chemical reaction. And I have, let me see if I can erase the extra things off top of this. Okay, imagine we have like this example here, okay? So I tell you, I have, half a cup of flour, and I have, 2.5, or let me write this. I have 2.5 cups of flour and half of eggs. You can half an egg, but let me write 3. And I say, how many pancakes, and then I have half a teaspoon baking powder. I say, how many pancakes can I make? So you see the equation is not that straightforward because I changed the number. So if I tell you, I have this much of the reactants or ingredients, how many pancakes can I make? But how would you say that? So how would we solve this problem? We first consider the first ingredient to be limiting reactant, and then we calculate the number of pancakes based off of that. That's not a, okay, I meant to use the eraser. So we say how many pancakes equals 2.5 cups of flour, okay? And I write a conversion factor that relates flour to pancakes. So what would be this ratio? 5/1, because you look at your recipe, right? This is your main thing that you're considering, okay? I don't put like 2 cups of flour gives me 5 pancakes. This is my recipe, okay? So these are recipe in making food or like baking pancakes would be moles in chemical reactions. It would be the coefficients in a balanced chemical reaction, okay? So let's continue with this example, and I go with the chemical reaction momentarily. So here, if you do the math, what would be the answer? 12.5, right? Pancakes. Are we good with this part? We calculate the amount of pancakes based on the first ingredient. Now let's do the second one. I say how many pancakes equals 3 eggs. And then I write a conversion factor that relates eggs to pancakes. What is this ratio? Exactly. And this would be 7.5, right? Did I write it correctly? Now let's do the next one. How many pancakes equals half a teaspoon baking powder multiplied by teaspoon baking powder and pancakes? What is this ratio? 5/2, right? Does that make sense to everyone? So this is 10, right? 10. Or you can say that this with this cancels out, so it would be 5 pancakes. So if I tell you that I have 2.5 cups of flour, 3 eggs, half a teaspoon baking powder, how many pancakes can I make? What do you think is the answer? Which one of these? 5, right? The one that is the smallest. Because although you have more than other ingredients, this one, which is baking powder, is limiting your reaction. And even, in this example, just by looking at this, you see that for other ingredients you have more, but for like baking powder you don't have more, so that limits your reaction. So if you remember this example, when you want to solve these types of questions, based on each of the ingredients, you calculate the amount of product that can be produced. And you look at the numbers. Whichever is the smallest would be theoretical yield. And I'm going to write this here. This is theoretical yield. And the reactant, I should write baking powder here too. Powder, you know what I mean. Baking powder. The reactant that is limiting the reaction that produces theoretical yield is your limiting reactant or limiting reagent. Does that make sense? Good? We have some definitions, which is like whatever I told you in the previous slide in like simple words in the language of pancakes, it would be in the language of chemical reactions. So we have one thing called limiting reactant. As we said, if we write a chemical equation such as this, and I gave you this in your homework assignment 2, and this is like a generic equation. It means like a general way of showing this equation without writing like each molecule or like each compound, okay? So if I ask you what are A and B, what do we call these? What are A and B? Reactants, exactly. What are C and D? Products, right? So if I go back to the previous slide, the definitions here listed, I typed them myself, and then I have like the screenshot of your book too. So the reactant that determines the amount of product formed in a chemical reaction. And if you got confused in the exam or your homework or your quiz, just remember the pancake example, okay? That if I don't have any eggs, I cannot make any product. So that limits my production of pancakes, right? So limiting reactant, in other words, is simply the reactant that makes the least amount of product. When I had like 1 egg, I could make 2.5 pancakes instead of 5. So that, makes the least amount of product when I write the conversion factors. And also theoretical yield is the maximum amount of product that can be made in a chemical reaction based on the amount of limiting reactant, what I just said, right? And theoretical yield is the amount of product that can be made in a chemical reaction based on the amount of limiting reactant. Kind of like just the same, just like different wording, but I included all of these. So when you see either of these in your exam, true or false, you know both sentences are correct. Any questions so far? Okay. And something that you should remember is that sometimes instead of reactant, we say reagent. They are like synonymous. So if I say limiting reagent is the same as limiting reactant. Okay? An actual yield, as I mentioned in the pancake example, is the amount of product actually produced by a chemical reaction. So this is the actual amount, okay? And always, I mean, most of the time, when you write something in theory, you know, when you have like a lab manual, you want to produce something, in theory, you can make much more than what you can actually get, right? Because in the experiments, you have like some errors, maybe you lose some materials, maybe some of it evaporates. So in theory, you know, you always have less amount of product than what you calculate. Does that make sense? So if you accept that from me, that the actual yield is less than theoretical yield, we can divide them by each other. And remember, actual yield is lower, is smaller than theoretical yield. So this is bigger or larger. So you should write this somehow that it would be smaller divided by, you know, larger. So it would be actual divided by theoretical yield multiplied by 100%. And we call that percent yield. So the only time that you write a ratio in these questions would be the time that you want to calculate percent yield, which would be actual yield divided by theoretical yield multiplied by 100%. Any questions so far? Are we good with the whole concept of theoretical yield, limiting reactant? Are we good with the concepts before I go through some examples? Good. Okay. And here again, you know, it's like just a repetition of what I just said, but I thought maybe if you have like the version of the book, you can read it better, or it's like more familiar. So it's just like what we talked about before, but I wanted to emphasize the definition. Back to the examples. So now let's go through an example, right? So in this example, we have like this. Consider this reaction. 2 aluminum plus 3 Cl2 gives 2 AlCl3. First of all, what type of reaction this reaction is? Can anyone tell me? Anyone? What's that? What is it? So precipitation reaction can be tempting because you see solid. But what was the definition of precipitation reaction?
It's when two aqueous.
Exactly. Precipitation is when you have aqueous plus aqueous and you see a solid form. So this is precipitation. So this is not precipitation. What else can it be? Can it be combustion? No, we don't see all oxygen on the left side or heat on the other side. What about acid-base reactions? Can it be acid-base? No. Acids have H, right? And then bases, they have OH, and then they produce water, right? So this is not acid-base. So what else it can be? Yes?
Redox?
Exactly. You have like a metal with a non-metal, right? So this is a redox. reaction. Okay? So this is the first thing. And then even, if I don't balance this chemical reaction, if I give you this in the exam, and I say balance this chemical equation. So how would you do that? So we have like two elements, aluminum and chlorine, right? So aluminum is balanced. So what about chlorine? How can so here I have 3 chlorine, here I have 2 chlorine. And remember, we always change the coefficient of the element that is by itself, right? Because if we change let me just do that just for the sake of demonstration. You may say that here we have 2, here we have 3. So if I put 2 over 3 here, these 3 and these 3 cancels out. I have 2 chlorine, right? Does that make sense, what I'm saying? So if you do that, then you should put, because now you have 2 over 3 aluminum, right? So you should put 2 over 3 aluminum here. So in this example, even that gave us the right answer. So in this case, it doesn't matter which one you do. I wanted to show you that, how difficult your life would be. But since aluminum is by itself too, it doesn't make a difference. But regardless, you should multiply this by 3, right? So it would be 2Al solid plus 3Cl2 gas gives 2AlCl3. Can you all see that? But the easier way, let me erase this one, AlCl3. Okay, AlCl3. The easier way is that to say that Al is already good. So here we have 3 chlorine atoms. So in order to have 3 here, we should divide 3 by 2, right? Because if I put 3 over 2, these guys cancel out. So I'll be having like 3 chlorine on the left too. Can everyone see that? 3 over 2. Good? And then we multiply everything by 2, which would be 2Al plus 3Cl2 gives 2AlCl3. Any questions? So I think this one was easier, but the other one works too, because you have Al by itself and also Cl2, so in that case you can do either of them. So this was just kind of like review of what we talked about before about balancing chemical equations. Now let's go to our question here. It says, so we have the following reaction, and it says if you begin, let me write the equation here so I can write things below it. And I advise you for the exam to do the same thing. If you begin with this much of aluminum, so 0.552 moles of aluminum, and this much of chlorine is 0.887 moles of chlorine, what is the limiting reactant and theoretical yield of AlCl3 in moles? So what is the name of AlCl3? Yes? Aluminum chloride, right? Aluminum chloride. Why didn't we write 3 in parentheses? Because aluminum has only one type of charge. It's always 3+. So for that matter, we don't write the charge in parentheses, remember? Okay. So how do you think we decide theoretical yield and limiting reactant? So for the pancake example, the example was really easy, right? when I was telling you, this is the recipe, now I have half an egg and then the same amount of other reactants or other ingredients. You could say that, okay, eggs are limiting reactants. It was straightforward. But when we have like moles and then we have coefficients in chemical reaction, so things are a little more complicated. How do you think I can decide which one is a limiting reactant? Anyone?
Whichever one has the smaller amount, like there's less of it.
Exactly, yes. But how can you decide that? So can you just like look at this and then easily tell me which one it is? Not that easily, right? It's just if I had like the numbers round and easy maybe, but now it's more difficult because we have like decimal places, we have like coefficients there. So what we do, we calculate the amount of product based on each of these. So I would consider that, okay, what if aluminum is my limiting reactant, right? And then I calculate the amount of product that can be produced. And I do the same with chlorine and calculate the amount of product. And then see which number is less, and that smaller number would be my theoretical yield, and the reactant producing that would be limiting reactant. And now I do that in practice so I can more easily see that. So if I want to calculate the amount of AlCl3, so I say how many moles of AlCl3 equals 0.552 moles of aluminum. So first, I do the calculations based off of aluminum. Okay, does that make sense? Just like this first step. So I calculate the amount of product based on the first reactant that I have. Okay, and I say how many moles of aluminum chloride equals 0.552 moles of aluminum. So how can I relate moles of aluminum to moles of aluminum chloride? Can anyone tell me? Anyone? So the hint is that we look at the balanced chemical reaction or balanced chemical equation. But how can we relate these two? Let me go back to the pancake example that we had here. So here you do the same thing, but remember, coefficients in a balanced chemical reaction are acting as your recipe, okay? So now if I ask you how many moles of aluminum chloride equals 0.552 moles of aluminum, now can anyone tell me what is this ratio? You look at a balanced chemical equation and read coefficients that are corresponding to aluminum chloride and aluminum. What is this ratio? 2 over 2, yes, thank you. So these two cancel out, these two cancel out. So this gives me 0.552 moles of aluminum chloride. Now we do the same for the second reactant. I say, how many moles of aluminum chloride equals 0.887 moles of chlorine? Multiply by a conversion factor that moles of chlorine cancels out, and we want to get moles of aluminum chloride. So what is this ratio? 2 over 3, right? You just look at these coefficients. So when you do this calculation, let me see what 2 over 3 multiplied by this number would be 0.591 moles of aluminum chloride. So which number is less? Which one? Above or below? This one or this one? This one is less, right? So this is smaller. So this is your theoretical yield. What would be your limiting reactant? Aluminum, right? Aluminum is limiting reactant. Okay. Now, let me go through another example. Okay. And this is your example 8.6. It says, consider this reaction. Cu2O solid plus carbon solid gives 2 Cu solid plus CO gas. And it says when, I guess I'll write the question real quick, 11.5 grams of carbon are allowed to react with 114.5 grams of Cu2O, 87.4 grams of Cu are obtained. Determine the limiting reactant theoretical yield and percent yield. Always remember that if you want to find theoretical yield, you should do some sort of calculation. But actual yield, I should give you an exam, or your book should specify. Because as I said in the baking pancake example, I say that this is the recipe, and then, you give me a recipe, and then you tell me, how many pancakes did you make? I say, none, I was lazy, I didn't, Or if I burn some, or if I drop some. So actual yield, you don't know, I should tell you. So here in this problem, when you read the question, it says, we have this much of carbon, and then write it here, 11.5, are allowed to react with 114.5 grams of Cu2O, and it says 87.4 grams of Cu are obtained. So your book is saying, this problem says that, okay, this much of the product we actually got. So what would that be? Is it theoretical yield, limiting reactant? Is it percent yield? What is it?
Actual yield.
Actual yield, excellent. This is your actual yield. And like the problem that I solved before, here you have more conversion factors. You should convert gram to moles, moles to moles, and then moles to gram. But the rationale, the procedure is the same. You find the theoretical yield and then divide actual yield by, you write actual divided by theoretical. And remember, this number is larger, this is smaller. Multiply by 100%, it would be percent yield. And I write the solution, bring it for you for the next class. But let's do the attendance. And even if you're watching the lecture at home, I put this questionnaire open because, I guess I don't have the office hours in this one. I open another one, as I said. I sent a link for you to fill out, and please do that. And if you don't study or don't go to SIPAS or don't go to tutoring and you got D or F on the exam, you're likely to fail this class. And I don't want that to happen. I do what I can to make sure that won't happen. So talk to me, and yeah.